All right, guys, in 3.5, we're going to do derivatives of the inverse function. So at the right of the graphs of f of x and its inverse. We know this because if you remember, the inverse function reflects over y equals x. The other thing to keep in mind about inverse functions is that in our coordinate, our x value and our y value switches for the inverse. Okay, so those are some things to remember when we talk about inverse functions. Okay, it reflects over y equals x, and that your x and y coordinates switch. Now, I want you to see based on these graphs, because if we talk about derivatives, we're talking about the slope. Is there something that we can analyze here between each point and their slope? Let's just take the AB, kind of predict what that slope's going to be. Now if we look at BA for the inverse and we look at that slope, what is the connection between these two slopes? I want you to think about that as we go through the example so I can prove to you what that is. So the first thing we're going to do is we have the function of x, square root of x. Now don't forget, with the square root of x, our x has to be greater than or equal to 0. Let's just remember our domain restrictions, which they remind us in part B, but might as well do it for the function in general. So in part A, we're going to graph. So 0, 0, when x is 1, f of x is 1. When x is 4, f of x is 2. Okay, so here is our square root of x. This is our f of x right here. Now, find the inverse of our function. Now remember, when we find the inverse of a function, we switch x and y, so we get x equals the square root of y squared, or y, not y squared. And remember that our domain restriction, x is greater than or equal to 0. So now when we solve and we square both sides, we get this y equals x squared. Don't forget, we're not talking about y, we're talking about the inverse of f of x. And we have to keep in mind, because think of this, an x squared is a parabola, right? But since we are only looking at x is greater than or equal to 0, now when we sketch it, what happens? Well, 0, 0 is still the same. 1, 1 is still the same. Now 2 squared is 4. So that looks about right, correct? Oops, sorry guys. So it's going over, there we go. So it reflects over y equals x, that makes sense, that looks good there. Now let's talk about differentiation. Let's think of what those slopes actually entail. So if I look at f of x, which is the square root of x, so in other words, think of x to the 1/2. Let's take the derivative of that. The derivative of f of x then would be 1/2 x to the negative 1/2. Okay? Now our f inverse equals x squared. So if we take the derivative here, make sure our derivative shows, we get 2x. Okay? Now it says find the slope of the graph of f of x at 4, 2, and the slope of f inverse at 2, 4. Now keep in mind, see how these coordinates are different, because of course the inverse, we switch our x and y value. This is going to become very important later on. So if I'm trying to find the slope at f prime of x, or f of x at 4, what I'm doing is 1/2 times 4 to the negative 1/2. Well, that's 1/2, and 1/2 times 1/2 is 1/4. So for f of x, the slope at 4 is 1/4. Let's try the other one. So I'm going to have my inverse derivative. But what am I doing? I'm actually I'm going to erase these x's here. Here I'm plugging in 4. But here, what am I plugging in for the value? I'm plugging in 2 because it's at the coordinate 2, 4. So that would be 2 times 2, which is the value of 4. What do these two slopes have in common? They are reciprocals of each other. Okay, so we have a function, we have its inverse, and the slopes are reciprocals of each other. Okay, but we have to remember that we're switching x and y. So this is a fancy way of saying what we're saying. If A and B is on the point of F, then BA, flipping that on the inverse, means that the derivative of the inverse is the reciprocal of the derivative of the actual function. Okay, again, this will make more sense on the next page. Okay, note, when finding the derivative of inverse functions, do not use the same x value, because if we do the inverse, the x and y values change. So this is why a table really will work, okay? So tables are going to be very, very helpful here. Let f and g be inverse functions so that f has the function and derivative values shown below. So f of x and f prime of x. So what does this mean? Instead of actually solving these, what we're going to do is continue this table. Okay? So f of x, we would have the point -1, 1, and the slope would be 3/2. Right? That's what we got just from this up here. But if we are talking about that g of x is the inverse, well, what does that mean for the coordinate? The coordinate means that it switches, and when we plug in 1, we get the reciprocal of that slope. Okay? So f of x, we have the point 0, 2. The slope is 2. But when we talk about the inverse, we switch our x and y. So then when we plug in 2 to our inverse, the slope is the reciprocal, which in this case is 1/2. F of x, we have the coordinate 1, 5. The slope is 1/2. When we do the inverse, which means we switch x and y, now when we plug in 5, we get the reciprocal of 2. Okay? Filling out the table will now help us figure these out. So don't forget, when we do g prime, we are looking at the inverse. And we also have to think that we are plugging in the y values for x, or the y values for f of x. Okay? So g prime of 1 means that I'm going to look at the inverse, and I'm going to look that x in this case equals 1. So my slope would be 2/3. G prime of 2, again, I'm looking at the inverse. I'm looking for x is 2, and my slope is 1/2. G prime of 3, so inverse, I'm looking for the x coordinate of 3, which we have none, so it can't be found. g prime of 0, so again, inverse, but I'm looking for the x value of 0, which we don't have one, so it can't be found. This is the one where most people will make a mistake because they keep thinking about this value and they want to do the reciprocal of this. But it's not. You have to switch x and y first before you figure out what you're plugging in. Because really, from f of x, we're plugging in the y value into our g of x. So f prime of 5, let's see, or g prime of 5, we go to our g, which is the inverse. 5 is our x, so our slope is 2. Okay. Last example. Okay, this one doesn't have a table, but I kind of want to do without the table and then show you what the table looks like. So you can decide if you need to use a table or not. So f of 3 is 28. Now, what we need to know is what is the slope at 3 of f of 3. So let's take our derivative. We get 3x squared minus 2. Then we're going to do f prime of 3. And when we plug in 3, we get the value of 25. Now, we want to know the inverse derivative of 28. If you look, that means it is the reciprocal of this. Now, how can I prove that to you in a table? Well, let's do it. F of x, we're taking the coordinate 3, 28, and the slope is 25. Now we have f inverse. That means our coordinate is 28, 3. And now that I know that it's the inverse, we flipped it and it's at 28, that means it must be the reciprocal of the other slope, of f of x slope, which is 1/25. So our answer is 1/25. The table will make it easier to use. All right, there you go.